I'm ready when you're ready.
All right. Yeah, I think we're ready. So let me do your introduction. And do you have any, are you doing this one on your own, or do you have co-authors joining you?
It's again only me presenting, but the work behind is cooperation between the University of Malta, the Maltese Education Ministry, and Danube University Krems.
Yes, I noticed on both presentations you have an international following, or set of authors. So let's get started. This is 1020. It's what role can blockchain-based digital identities play to counteract cybercrime in relation to the assessment results and credentials in the educational sector? A glimpse into the future. And this is Alexander Pfeiffer from MIT. Take it away.
Thank you. I'd like to give you with this talk like a sum up of my last 2 years research at MIT. I'm now back in Austria at Danube University. And as I said before, this is a cooperation between the University of Malta, Vince Weller, Alexi Tingley, Simone Kriegelstein from the University of Vienna, Thomas Wernbacher from Danube University, Krems in Austria, and Stephen Bezzina from the Ministry of Education in Malta, because Malta has quite a blockchain-friendly legislation, and they are quite interested in developing blockchain-based applications and ideas. Why is it important to secure learning credentials? Because our learning credentials have, on the one hand, a lot of value, because they can decide if we are accepted for a new job, if we are accepted to study at a university. And so therefore, it's also a huge market, so to say, for criminal activities. To give you like a personal example, one of my master degrees is in the US, from APU in Anchorage. And you get a certificate, and it says it's an original if it's printed on blue paper. So mostly when you apply for a job, or when I applied for my second PhD in Malta, what they do is the officers there take the piece of paper, they read there like a nudge, it's an original printed on blue paper, and what they do is they look if it's printed on blue paper, and then they trust you and they accept you. And I guess in 95% of the cases, they will not call APU and have a look if this is a real certificate. And now in Europe, cross-border, it's even more difficult with privacy rights, because you as the holder or the possible holder of the degree, you always have to give your agreement that background checks at the university can be done. So it's nearly impossible to conduct background checks on the credentials of a person applying for a job. Thanks to Dorothy and her great talk, I can speed up a bit in regards to explaining blockchain technologies, because this was a perfect introduction. But if anyone is new here, I sum it up quickly. So blockchain technologies are considered to be part of DLTs, distributed ledger technologies. But there is a huge difference, because with blockchain, as the name says, the transactions are grouped into blocks, and those blocks are cryptographically connected with each other. How is such a block defined? It's depending on the different blockchain systems. So on the market, there are thousands of different tokens with different use cases, and just a handful of trustful blockchains. But it's some of those blockchains, like Ethereum, like NXT, like Ador, you're capable of creating new tokens with a unique asset ID upon the blockchain. So that is why there are less blockchains than actually tokens, just a side mark. And how those blocks are generated, it depends on the system. It can be after a particular amount of time. It can be after a particular amount of stored data. It can be after a particular amount of actual transactions in a block. The hash function is important, because a hash function maps the input quantity to a smaller target quantity. No need to explain it to you at the cybersecurity conference. And those blocks actually start with a unique hash, end with a unique hash, and it's always like the second block starts with the hash of the first block, the third block starts with the hash of the second block. Those blockchains can be public, consortium-based, private, and permission or permissionless, meaning that everyone has access or only a small group of people. And if you design blockchain applications, you always have to have in mind that for a public blockchain, you have, of course, to pay the transaction fees, while for a consortium-based blockchain, you obviously trust each other, and that each of your computer systems, for example, if in an educational sector, each Ministry of Education runs their nodes, they would not pay transaction fees between each other. But what is often happening is an interplay between both. So basically what you do is you send the hash of a newly created block, not of all transaction, but the hash of each block, then to the public blockchain. And with that little trick, you can still be sure that although you have 100,000 transactions in 10 minutes, you only send one particular hash file to the public blockchain. So you make sure that the transactions on the consortium-based blockchain cannot be altered afterwards. And before I spent the last 2/3 of my talk actually on education and tokens, we have to speak a little bit about different types of tokens. And what we as a research team thought, or because there's no common sense yet, is that we talk about non-tradable utility tokens. So those are tokens registered on the blockchain, but we make sure with approval models, we make sure with whitelisting accounts, et cetera, that those tokens that we create, because they actually store your learning credentials, cannot be freely traded from one account to another. Only with the permission, for example, of the university, such a token can leave the account and send to another account in rare cases. So Dorothy already was talking about smart contracts, and I add here lightweight smart contracts. And the difference is that with smart contracts, it's like clay. You can freely build your apps, and with lightweight smart contracts, it's like playing around with Lego. And what I do in most of the applications that we design is we play with lightweight smart contracts, because here you can be more or less sure that your smart contracts cannot be hackable. If we read a lot about blockchains that have been hacked, it's not the blockchain itself, it's mostly an issue in the smart contracts. That is, for example, locking the transactions or the cryptocurrencies. My point, or our point, is that on the one hand, we have blockchain technologies as a very safe way how to secure data and store data and share data, giving access with a shared key to look into particular data. What we are missing out in most of the times when we speak about blockchain is this needs to be connected with a safe digital identity of the person or entity representing what has been actually put into the block and what kind of data has been saved on blockchain. And in regards to digital identity, of course, we know many different forms. We have our passports, we have our social media accounts, you have your bank account with your digital ID related to it, or in the European Union, we have the eIDAS regulation. So for example, in Austria, we have the A-Trust, our trust center, and the trust center is providing digital identities to the Austrian citizens. While this is mostly working within a country and quite well working cross-border in the European Union, of course, it makes no sense to sign a PDF digitally. If I sign something for the MIT administration, for example, so they still want the blueprint signature, or the systems that MIT provide, obviously. And there are two particular trends in regards to blockchain and digital identity. One is from the Sovereign Foundation to store your digital identity in regards to self-sovereign identity. What we are working at is DID from the W3C Foundation, so they give the specifications. We create DIDs on the other blockchain, and we connected the DIDs with the domains of the research institutions in our use case that we presented in the paper with the domain Danube University. Of course, there's still a way to fraud because if you have access to create email addresses on the domain, you can of course create Max Mustermann at Danube University, and our system would then at least accept it as a valid address from Danube University. So it doesn't matter what kind of technology you use, there's always this small possibility of fraud, especially when someone with a gun puts a gun on your head and tries to force you to do something. And of course, these digital identities can later on, this was my talk at the AI conference from ACPI, have to be connected with digital agents at a later stage of time. And this is maybe, I have 5 minutes left, this is maybe one of the most important aspects of our research work. So what we do is we say we have this blockchain wallet, like as we are used to holding cryptocurrencies, but in our case, it's holding those utility tokens that have a special use case. like health data for the COVID crisis, or in our case here, holding the learning credentials. These tokens that are in your EIT wallet as a person, they can be connected with a particular digital identity that the use case defines. It can be your verified Twitter account. It can be all sort of DIDs or self-sovereign identities, or it can be, for example, the A-Trust signature in Austria. And then you share the data in most of the time with your shared keys. The shared keys give a particular person access to read the metadata that has been attached to the token. And this has to be done through multi-chain processing. So what we do is we use the other blockchain, but the other blockchain allows, for example, ERC20 compatibility with Ethereum. So although we use a smaller blockchain, we're still capable of working also with Ethereum transactions. And then at a later stage, again, you can also include digital agents here. And I'd like to give you now, for the last 5 minutes, some examples in the educational sector, where you can use utility tokens that hold particular data. You can use it for conducting a single assessment, for storing a set of grades as a part of an assessment, or to store your final exams and your certificates. And while the MIT project Block Search from Learning Machine is doing this in a way that there's a one-way hash created. So basically it proves that the PDF document and the hash data of the PDF document is an original. Our project is kind of unique because we also include metadata, like the curriculum behind the syllabus, the timestamps, the teachers involved, whatever data you think it's necessary. And the project was 3 steps. One step was creating a digital serious game. Second step was creating an e-learning assessment environment. And the third step, which I spent the next 3 minutes, is actually creating a certificate after you passed your waiver, after you passed your final exams. And you can see all the transaction IDs and everything in the paper, in the proceedings. So just some screenshots to explain the procedures. We have a blockchain address that we said it's representing our university or our center at Danube University Krems. And to prove that this is our address, we used our Facebook account. But of course, in real life, so to say, the address could be listed on the university website, or the address could be listed on a government register where all the blockchain addresses used from the different research institutes and universities and colleges and schools are listed. So you can always have a look if this is real data stored from the official blockchain address of the institution. So we start with a list of the enrolled students. We don't list the names, just again the blockchain addresses. So data projection is given. And then we set up different approval models for the utility tokens that we create on the network. So for example, that the examiner and the official university account has to agree that the token with all the metadata, the grade, etc., is sent to the student. So this is here the asset and the asset description. This token certifies a successful completion of the master thesis. And this is the token after everyone agrees it's legit, is being sent to the student, and the student cannot resend it. He only gets this shared key so that he can share the results. And then what we did is we combined it with Moodle. So we created a real certificate on Moodle with all the digital IDs in it, with all the metadata in it, and the blockchain addresses used. And as we have this interplay between public available information like, okay, this is a certificate, and on the other hand, the valuable metadata that you just want to share with particular persons, we designed to create different kind of tokens involved in these projects where you can also read the descriptions and our thoughts behind in detail in the paper. So also the teacher receives confirmation in our use case, but to conclude, and so this is like, I know it's from a graphical point of view, it's not the best one, but it's just to show you the work in the proof of concept. So we have a certificate that can be printed, that can be stored on paper, and this certificate includes different transaction hashes. So on the one hand, the transaction hashes on Ardor testnet in our case for the non-encrypted digital proof of the certificate. The second one, which is non-encrypted, and then the encrypted data, which is the metadata related to this particular certificate. And for fun, we also created here a best paper award address. Then we have the blockchain address printed here from the Center of Applied Game Studies, and the reference where you can look up that this is a legit address. And at the very end, we give the information to the user that they either should install the full node themselves, use a lightweight wallet, or in this case, if you like to have a quick check, just click on test.otherportal.org and then put all those transaction hashes listed here in on the portal to actually have a look into transactions. And if you use the shared keys provided in the paper, you can also decrypt the messages. So again, 15 minutes. I'm happy. I hope you like the topic. Thank you.
All right, that is awesome. So on time. So I do have one. I've got a question in the chat from Ann Conkey that says, if degrees cannot be verified, do employers think less of them?
Well, they can be verified if you, as someone applying for a job, agree that you give them the right to verify it. So of course, if you try to get a job as a CEO of a company, every credential that you provide will be verified, and the companies take the resources to do so. If you apply for a lesser paid job, or if, as in my case, applying for this other university, I don't think that they actually called the other university and verified, and they did not ask for the permission. So that is why our approach is that if we secure all this data on blockchain, then we would finally have this opportunity that I simply provide you my shared key. And with the shared key, you can look at the different blockchain addresses. You can look at the you can decrypt the metadata. And then you have to do, of course, some research. If I frauded the whole system, and if I just tried to give you a frauded certificate pretending that everything is safe and sound on blockchain, or if it's the real blockchain addresses used by the universities. And this is why we always need this two-factor authentication kind of thing with a register on the website of the school. So if you are a hacker, you would need to hack the website of the school, put the blockchain addresses there that you used for your fraudulent approach. So acting in a fraudulent way would be much harder than just than just printing a certificate from APU on blue paper and hoping that no one is checking it.
Right. And the reason, if I could interject, the reason I even asked the question was I worked with I was a hiring manager for many years in the corporate ranks, and we do have obviously databases here that we can check to see if the degrees are real. But back before they were even available, I had a colleague that fabricated that he had 3 bachelor's degrees, and nobody was the wiser. And it was a slip of his tongue from his sister that I found out that they were all fabricated. And it would just happen to be, I was at a social event, and I'm thinking, oh my goodness, how I never said a word to anybody. I just thought that is absolutely, so this technology is outstanding. I thank you for your presentation. Both of them have been really great. I'm just curious, how far away what's the possibility that this technology will be implemented in these software applications to verify this? It's
from a tech perspective, it's there. You can work with it. You can try all that we developed at MIT, at Danube University in Malta the last years. It's a political decision. It's lobbying for the technologies. Politicians and policymakers have to understand that we are not using this blockchain as a fraudulent whatever or for speculation, but actually as the most secure database available. And I think in 2045, we are not having this discussion, and it will be picked up, and every data that is reliable to us humans will be stored at some point on blockchain. But for now, it's education, like we're doing here at this conference. But this is a high-class cybersecurity conference. Imagine the same talk at the teachers' conference, right, where you have to, of course, explain more the technology in the background. But it's all catch me if you can. I think, like in your case, if you overdo it, if you fraud 3 bachelors, at a certain point they will find you. But if you just fraud 1 bachelor, if you get your job and if you stay calm the rest of your life on the job, they might not catch you. We have 1 minute left because was a personal example. I was a mentor in a startup program, and the person applied as a doctor, And the university was calling me and telling me, she's not a doctor, this is frauded, but I can't give you this information officially. And then we were not able to get this information officially because we would have needed to ask her to give us the permission. But to be part of the started program, it was not needed to have a doctorate. So we as a team were not capable of asking her for the permission to check her doctorate. So this is a short story and something that inspired me to to go to MIT and then do the research there the last 2 years.